Hi everyone, my name is Junlin Zhao. My teammates are Yujun Shi and Shaoqi Zhou. Today, we want to present the big data analysis on Taiwanese stock market. For the motivation, stock investors can be partitioned into two groups. And one is individual investors, which is called small players. And the other is institutional investors. We can call that big players. And we will discuss the issues mainly on the small players for the investment of stock market. And they may be unfamiliar with rules of stock market. And second, they have limited unusable capital. And third, they may be misled by some fake information, which is spread by social media. To help them have the positive annual return on investment, we decide to analyze the data on the stock market. First, we will introduce some tools and algorithms and data we use. For the data set, we use the data from the Taiwan Stock Exchange Corporation, which has provided the stock data since 1992. There are up to 900 companies on the stock market, and for each year there are about 250 trading days. And for each trading day, the data size is 0.3 kilobytes. So there are up to 1,800 megabytes of the data set size. For the API tools, first we use String.io, which is used to send requests to the website of TWSE. Then we quote data from that website. Finally, we output the data as a CSV file. Besides, we use NumPy and Pandas, which are basic tools for the data analysis. And then we use TA library, which is technical analysis to compute exponential moving average. And last, we use Matplot library, which is a function for collecting and analyzing data and make several plots for the data. Especially, we use MPL Finance to plot candlestick chart, which is significant for analyzing the trend of the stock price. For the application of algorithm, we use three typical regressions to analyze our data. First is linear regression. It is to predict the response y on the basis of a single predictor variable x. And the second is decision tree regression, which is composed of nodes and edges to represent the possible paths for the prediction. And the third is the random forest regression, which is the example of untrained decision trees with some bootstrap samples. Here are the example results of the regressions we used.
In this part, I will tell you our trading strategy. First, we'll use our stock screener to unweight most stocks, and then perform backtesting for every stock we pick. And backtesting is based on modified double cross method. In the first step, we pick those domestic institution and foreign investment institution has bought within 5 days. Every investor can access the information on a daily basis in Taiwan's stock market. It's a transparent financial information for every individual investor. This process will filter out most stocks. And in the second step, we can use an EMA system to pick the stocks that are in uptrend. Compared with SMA, EMA responds faster to price fluctuation. It gives more weight to recent periods and thus more emphasis on what traders are doing at the moment. After stock picking, we'll start backtesting with a modified double crossover method. Before that, I want to introduce a conventional double crossover method first. The conventional method is quite easy. We set two moving averages, and we buy when there is a golden cross and sell when there is a dead cross. This strategy is too simple and thus can give high benefit. So we use a modified double crossover strategy instead. We also use two moving averages here, a short EMA and a long EMA. We buy when the following criteria are met. The stock price is greater than the value of the short EMA. The slope of the short and long EMA must be positive. The ratio of the short and the long EMA must be greater than 1.02. And finally, the current price must be above 50-day EMA. And for stock selling, we sell when the slope of the short EMA is less than 0, or when both the slope of short EMA is greater than 0 and the trading value is 2.2 greater than yesterday. This means that we sell when there is a pullback in price or when there is a surge in value. We perform the strategy recursively for many EMA pairs based on 2-year historical data for individual stocks and obtain the EMA pair that corresponds to the highest ROI. Here's the definition of ROI. It is the gain from investment minus the cost of the investment over cost of investment. Also, we'll show our win rate. The definition of win rate is the wins over transaction count. Here's one of our results. The EMA pair is shown on the picture, which is only for a certain stock. The obtained EMA pair corresponds to best ROI of a certain stock using our trading strategy, is shown in the rectangular.
And we are going to construct a website interface to show our results. We implement the algorithm mentioned before here and construct them into a Python program. It will generate a CSV file containing a list of stock ID and the rate of investment. And it will also generate JPG files of candlestick plots. Then we write HTML, NL, and JavaScript to control the website interface. In the result, we can use web browser like Google Chrome to selectively show the images and the rate of investment calculated from the Python program. Here are some basic functions we write in HTML and JavaScript. We declare a drop-down list and a button in HTML, and in JavaScript, we use jQuery to import CSV file to an array, and according to the data in the array, we append the option to the drop-down list. Then here is the result of the website interface. We here have a drop-down list. You can select the stock ID and click the show button. It will show us the candlestick plot and the layer ENA curve and the rate of investment and the win rate. In conclusion, we crawl stock market data by using string IO and request, and we analyze the trend of price with several regression methods. We also optimize translation by using modified double crossover method. Finally, we construct a website interface to show the candlestick plot and the rate of investment.
Here is the source code part. First, we import the packages that we need. We import requests for web crawling. We import string IO to read and write strings as files. Import pandas, import numpy, and import datetime to get current time. And import relative delta to offset days or months. Import myPlotLib to plot. Import CSV to export our data frames as CSV files. And we import pytz to get datetime in certain time zone. Next, we define a function called dateGenerator. In this function, we get dates and convert datetime object to strings. And notice that we skip weekends here, so we can run the program not only at weekdays. And then finally, the function turn dates to strings. Now we turn to the main part of the code, stock screening, step 1. In this step, we screen out most stocks and only pick those that DIIs and FIIs has bought within the last 5 days from today. This information is transparent in Taiwan's stock market. The first step is that we crawl data from TWSE, Taiwan Stock Exchange Corporation, and then convert them to strings and convert them to data frames. And now we remove most columns and only keep the columns that are related to DII and FII. And notice that we have to remove commas and convert strings to integers here. And then only keep those that both DII and FII has bought within recent 5 days. Now we have to deal with days. We get current local time in Taiwan and append data frames to DF list within recent 5 days and concatenate the 5 data frame within the last 5 days from today. After use group by and sort the picked stocks in an ascending order according to the number of days both FII and DII has bought. We get the result. Okay, give me a minute. Okay, that's the result. Now we have to do step 2 of stock screening. Here we use an EMA system that involves 5-day, 20-day, 50-day, and 100-day EMAs. And first we have to pick stocks whose prices are in uptrend. And the second criterion is that the slope of EMA 20, EMA 50, and BMA 100 should be greater than 0. To analyze those EMAs, we have to get data within recent 6 months. Here we crawl data from another website, not TWSE, just another website about stocks. And then we have to deal with the dates in a different way because they are not in an AD date. So we filter out, and we have to filter out blank data frames. Now to calculate EMA, we have to import another package called tlib. This package cannot be directly installed by using the pip command. So let me run the program. Okay, now we get the date 6 months from now. And then we start picking the stocks by stock screening step 2. It will take a lot of time. Okay, it's over. And now save the result in a list called RES list. As you can see, there are 32 items that satisfy our criteria. Next, we start to do backtesting. Here we use a modified double crossover method instead. Follow a set of criteria. When the 4 criteria are met, we buy. And when the following criteria are met, we sell. So first we have to crawl data within the last 2 years from this website. It's a very time-consuming process. So let's do it. Here we successfully crawl data within the last 2 years from this website. And now we need to perform backtesting. Here we defined a function to calculate ROI and win rate. And for the main part of backtesting, we defined a shorter EMA and a longer EMA. But we don't know exactly how long their periods are. Based on the 2-year data, keep selling based on this criteria, and buy based on this criteria, according to our modified double cross method, and do this recursively to many EMA pairs. Here, the short EMA range from 2 to 8, and the longer EMA range from 12 to 21. And finally, we will obtain the EMA pair that correspond to the highest ROI for individual stocks. And here we will export our result to a CSV file. We will export stock ID, transaction count, ROI, and win rate. So let's run the program. Okay, and write our result to a CSV file. To draw candlestick plots to visualize our results, first we must convert our days to AD days, and then convert datetime object to matplotlib days, so we can draw candlestick plot from importing this library. So let's do it. Here we plot the EMA pairs that suits all stocks we have picked, and save the figures as JPEG files. We have also tried to use Spark regressions to predict future stock prices, but the result is not satisfying, so we decided not to make further discussions here. Here we first load the packages that we need. We load linear regressor, decision tree regressor, and random forest regressor. So let's load them. And then we load data from Yahoo Finance API from August 1st to November 28th. Okay, after the loading is over, we set the date in another form. And we set moving averages. Set our trend data size to 60. And start our linear regression model, decision tree regression model, and random forest regression model. Finally, we draw a candlestick plot to visualize our results. Here, as you can see, the trend data is on the left of the aqua blue line, and the predicted result is on the right. And none of the regression model can make correct prediction. So, because the stock price movements deviate significantly from the predicted result, we decided not to use the Spark regressions.
In HTML, we declare a drop-down list and a button for click, and in JavaScript, we write a function about adding image when the button is clicked, and we use jQuery to read CSV file as an array, and according to the data from the CSV file, we append option to the drop-down list. Then if we launch the HTML and the JavaScript to the website, we can have an interface like this, and we can click on the drop-down list to select the stock with information we want to show, and here we can see the transaction number and the return of investment and the overall win rate of our investment, and we also have a candlestick plot for our investment based on our algorithm calculated by the Python program. And we can continue to show the candlestick plot and the other information calculated by the Python program.